Okay, we're picking up where we left off. Problem 35, still doing trig. We're going to be doing trig through all these problems. In triangle ABC, because that was pretty much fourth quarter, in triangle ABC, the sine of A is a half, B is 20, and the measure of angle B is 45 degrees. What is the length of side A? Well, you can't count on this being a right triangle. I would draw a picture of what's going on here. Let's say that this is ABC. Okay, let's say that this is 45 degrees. Let's say that B is 20, because this would be B here, this would be 20, this would be A, and this would be C, opposite the angles, corresponding lowercase letters. And we are trying to find the side of A. We're trying to find this guy. Well, what do we know? Well, we don't know what the angle is, although we could figure it out, but we know that the sine of A is a half. So this looks like that I've got angle, some information about the angle, and side. So angle, side, that's the law of sine. So I'm going to say that the sine of A over A is equal to the sine of B over B. Now, it's also equal to the sine of C over C, but I don't have any of that information, nor am I looking for it. Just the A's and the B's. Now, I know the sine of A is a half, and I'm trying to find A, and then this would be the sine of 45 degrees, which I actually know from my unit circle, and that is over B, which is 20. So I cross multiply, I get A times the sine of 45 degrees, which is the square root of 2 over 2, is equal to half of 20, which is 10. So that means I have the square root of 2 over 2 times A is equal to 10. I'm going to multiply both sides by the reciprocal. I know that looks awkward. Times the reciprocal on both sides so that I can get the A by itself. So this is 20 over the square root of 2, and I'm going to have to rationalize the denominator. So that's going to be 20 square roots of 2 over 2. Square root of 2 times square root of 2 is 2. And 20 over 2, that's 10 square roots of 2. That should be my answer. That was messy. I didn't leave myself enough space there. Hopefully you can see that all right. And I did kind of go fast, so if I went too fast, rewind and go back. Go through it again. Slow me down. In triangle ABC, the measure of angle A is 75, the measure of angle B is 40, and B is 35. What's the measure of angle C? Well, they give me 2 out of the 3, and I need the third angle because it looks like it's going to be another angle side, and I need to know what C is. So let's say that this is A, and this is B, and this is C, and I know that this is 75, I know this is 40, 75 and 40 is 115, that means this is 65, using the fact that all three interior angles of a triangle, their measures have a sum of 180. And what do I know? I know B, which would be over here, is 35, and I'm trying to find C. So it looks like I'm not going to do anything with angle A. I'm going to still use the law of sines. I'm going to write that the sine of 40 degrees, that's B, all over B, which is 35, is equal to the sine of 65, because I want to know what C is, and so I have to use angle C there. I think this is the one where they don't actually multiply it out, which makes me think he's not going to let you use a calculator. I don't know for sure. Let's see. Yeah, he just writes it out as trig expressions here. So I cross multiply. I get C times the sine of 40 degrees is equal to 35 times the sine of 65 degrees. And to solve for C, I just divide both sides by the sine of 40 degrees. And I get C is equal to this expression right here. Hopefully that matches something. Did I get it to match? I got it to match. Looks like answer D. Two sides of a triangle measure 6 and 8, and the measure of the included angle is 150. Find the area of the triangle. Well, we did one just like this in the other video. Remember, 1/2 times one side times another side times the sine of the included angle. So this is, the area is going to be 1/2 times 6 times 8 times the sine of 150 degrees. So this is 1/2 times 6 times 8. The sine of 150 degrees is a half. And you say, well, I don't have it memorized. I know I should have memorized it, but I don't have it memorized. Well, draw it out. Well, maybe not draw it out there, because then I'm going to go into the next problem here. Here, let's draw it out. Let's see. I mean, as you can see, it's going to slow you down. Here's 150, right? So that means this is 30, and if you're using a unit circle, this is 1, this would be a half, this would be the square root of 3 over 2, so square root of 3 over 2 to the left, half up, that means this is negative square root of 3 over 2, 1/2, and there's my 1/2. The sine of 150 is the y. So let's see, half of 6 is 3, and half of 8 is 4, so this is 3 times 4, which is 12 square units. I don't think there were any units given, and they only have a 12. Now, it gets a little interesting. It says, what's the equation of the graph shown below? Now, notice how it starts at 0, 0 here, but it does go up to 2, and it does go down to negative 2, but it does a complete cycle in terms of 2 pi, which is perfect for sine. It's just that the amplitude's been increased. Now, the parent graph of y equals the sine of x would go more like this. Everything's the same except that this has been vertically stretched, and we get that by multiplying the sine of x by the appropriate constant, which in this case is 2. We want to double the amplitude. So this is 2 sine of x. And there you go. Now remember, if the 2 is in here, that doesn't affect the amplitude, that affects the period, which I think gets us to problem number 39. In problem 39, not on this page, I'm going to go ahead and publish this guy. Okay. Let's see. I am asked to find the equation, okay. Now in this case, notice that it peaks up here at 0, 1, and goes through pi over 2 down here to pi. Now that tells me, if I continue my graph, that looks like a cosine because it goes up here at 0, 1. And that is 0, 1, right? So there's not been a change in amplitude. It's not been shifted or translated in any way. And the period is still 2 pi, so this is just good old y equals the cosine of x, the parent function itself. So that one kind of tried to fake you out because they only gave you half the period, thinking that maybe you would, multiply this by 2 or by half or something here. But that's just good old y equals cosine x, which is hopefully a choice. Answer A. Now, I like this problem, and I like this problem because if I know a couple facts, these are easy. There's no work to show, there's nothing. Here's a right triangle. Here's a set of axes. I'm tired. All students take calculus. All right, they're all positive. Sine, cosine, tangent, positive in the first quadrant. Sine is positive in the first, but cosine and tangent are negative. Tangent's positive in the second here. Tangent's positive in the third, but sine and cosine are both negative. Cosine's positive in the fourth, but sine and tangent are both negative. And it says here that the sine and the cosine are both less than 0 for this angle. So it's a third quadrant angle because they're both negative here. So what quadrant does it terminate? Quadrant 3. Now in this case it says tangent is positive. Now tangent's positive in the first and in the third, and cosine is negative. Well, cosine's positive in the first, negative in the third. It's also quadrant 3. Look how simple that was. All students take calculus. All right, if placed in standard position, an angle of 11 pi over 6 radians has the same terminal side as an angle of. We just had this in the previous video. Only they changed everything into degrees, but I think this time they left it in radians. This is number 42. Nope, son of a gun, they converted it back into degrees. Okay, 11 pi over 6. That's over this, well, I had it once before. 11 pi over 6 is all the way around like this, where this angle right here is pi over 6, because 11 pi over 6 is equivalent to 330 degrees. So this is 30 degrees this way, or negative 30 degrees. Now what are my choices here? Well, answer C. It's negative 30 degrees because 330 degrees and negative 30 degrees, although they are different angles, one's positive, one's negative, in standard position they are coterminal, and therefore their sines, their cosines, their tangents, everything are the same. They have the same terminal side. So your answer is negative 30 degrees. The number of degrees equivalent to 5/9 pi. Well, to change 5/9 pi into degrees, you multiply it times 180 over pi. And you say, well, what if I got it backward? Well, then the pi's won't cancel. And that'll be a big tip-off. You get pi squared, so you know that. So I'm just going to go ahead and cancel those. I can cancel 9 here with a 9 here. That's 20. So it looks like 100 over 1, or 100 degrees. Easy pleasy. What is the value of the cosine of negative 120 degrees? Well, maybe negatives aren't your cup of tea. Add 360 to it. Get a coterminal angle. If I add 360 to negative 120, I get 240 degrees. Now, you say, I don't know the table. Draw it out. 240 degrees. There's 180 and 60 more. So this is 60 degrees here. Draw your right triangle. This is going to be another 30, 60, 90. And this is side 1 because it's the unit circle. So to go from here to the shorter leg, I take a half. From the shorter leg to the longer leg, I take multiply by the square root of 3 over 2. So this is negative 1/2, negative square root of 3 over 2. This is my cosine, this is my sine. I want the cosine negative 1/2. Look how much faster it would be if you just memorized it. Now, back to graphs, except we don't have to graph them, we just have to talk about the amplitude and the period. Okay, remember the coefficient that's multiplied times the trig function, times the sine of the cosine. That's what affects the amplitude. Your amplitude is the absolute value of this constant. It's 2. You say, what about the half? That affects the period. Speaking of period, it says, what's the period of the graph of this equation? Well, you take the period of the parent function, which is 2 pi, and you divide it by the constant that's times the x. So it cuts the period in half. The period is now pi. So we're almost done. I don't know if we can get all, what do we have left? 9 more problems, counting the 4 multiple choice and the 5 free response. I don't know if we can squeeze them in one video, but maybe we'll try to do that because I'm sure you're getting tired of me talking. Hopefully this is helping you out.